You know that feeling, right? You're standing at the baggage carousel, just watching it go round and round. You see a bag that kind of looks like yours. Nope, not that one either. While we're all just standing there with that little mix of hope and anxiety, there's this massive, high-speed, and incredibly complex system working just out of sight. So let's pull back the curtain on that hidden world, and we're going to start with a time when it all went spectacularly wrong.
This quote pretty much sums up the scene at the grand opening of London Heathrow's Terminal 5. I mean, imagine this, a 4.3 billion pound project, years in the making, designed to be this shining example of modern travel. And on its very first day, all that pride just evaporated into a complete logistical nightmare.
23,000. That is the number of bags that got stranded in just the first 5 days of T5 being open. More than 500 flights got canceled. It was a total meltdown. And the heart of the problem was the one thing that was supposed to prevent all this: the brand new, cutting-edge baggage handling system.
So how could a system this expensive, this advanced, fail so badly? Well, it wasn't one single broken part. Oh no, it was a whole cascade of seemingly small problems that snowballed and brought the entire operation to a grinding halt. The problems just kept piling on top of each other. First, staff couldn't even log in to do their jobs. Then, a software bug meant the system couldn't read the bag tags correctly. So it essentially panicked and started sending almost everything to be sorted by hand. But of course, there weren't nearly enough people to handle that kind of volume, so the conveyor belts just stopped, completely choked with a mountain of luggage. That T5 disaster was a huge wake-up call for sure. But it really shines a light on a challenge that every major airport in the world has to deal with every single day, just an almost incomprehensible number of bags. Globally, airlines handle over 4 billion bags every single year. Just let that number sink in for a second. Moving that many pieces of luggage from the check-in desk to the right plane across these huge airport campuses, it's honestly one of the great logistical puzzles of our time. And to be fair, the system is incredibly good. I mean, a 99.6% success rate, that's fantastic in pretty much any industry. It means that the overwhelming majority of the time you fly, the whole thing works flawlessly. But what happens when you apply that tiny, tiny failure percentage to a number as massive as 4 billion? Well, that tiny little 0.4% ends up being about 64 million mishandled bags every year. So lost luggage isn't just a headache for you and me, it's a massive, ongoing, and really expensive problem for the entire airline industry. So how in the world do airports pull off this incredible feat? The answer is this amazing symphony of high-speed machines and really smart software. It's kind of like an automated ballet happening right under your feet. You know, in these huge modern airports, the distances are just enormous. A regular old conveyor belt is way too slow to get your bag from check-in to a gate that's on the other side of the terminal. To keep things moving on time, they had to invent something much, much faster. And here is the star of the show, the Destination Coded Vehicle, or DCV. The best way to think about it is like a personal little taxi for your suitcase. Every single bag gets its own cart, which then zips through this huge, complex network of tracks, almost like a miniature railway system just for luggage. And these things are fast. Seriously, we're talking up to 45 miles an hour. They use the same kind of magnetic propulsion tech you see in modern roller coasters. That kind of speed is absolutely essential to get a bag from one end of a sprawling airport to the other in time for its flight. Okay, so you have the speed, but a fast body isn't much use without the intelligence to guide it, right? So now let's look at the sensors and the controllers that act as the eyes, ears, and brains of this whole operation. So picture this. You've got thousands of these little high-speed carts zipping around. How does the system make sure that DCV number 7532, which is carrying a bag headed for Dubai, takes the correct turn, instead of accidentally ending up on a flight to Dublin? Well, it all starts with the senses, the automatic tag readers. For a long time, lasers were the go-to. Then came RFID tags, which are awesome because they don't need a direct line of sight. And now we've got these advanced camera systems that can read even crumpled, dirty, or damaged tags, which, as you can imagine, boosts the success rate like crazy. So once the bag is identified, the first layer of the brain kicks in. This is the Programmable Logic Controller, or PLC. A really good way to think of a PLC is like a local traffic cop at one single intersection. It takes in the data, like where the bag is going, and makes a super simple, instantaneous decision. Go left or go right. And these decisions are anything but random. Every single action a PLC takes is based on a really carefully developed program.
Engineers literally map out every possible scenario. The key thing to understand here is that every split-second choice is pre-planned and tested again and again to be as rock-solid as possible.
But, having thousands of little local traffic cops isn't enough. You need a citywide traffic management system, something that can see the whole picture and prevent total gridlock. And that's where the highest level of control comes into play.
This is what's called the hierarchical control model, and it's basically the network's mastermind. It's not worried about your specific bag. Instead, it thinks in terms of flows of vehicles, kind of like managing traffic on a highway system. Its job is to look at the entire airport and optimize all these flows to prevent jams and make absolutely sure every single bag makes its flight on time.
So you can see the whole hierarchy laid out here. At the very top, you've got the network controller. It's planning the big picture flow, thinking in a time scale of minutes. Then, it sends commands down to the switch controllers, which are operating in seconds. And all the way at the bottom, each individual DCV is making tiny little adjustments in milliseconds to manage its speed and avoid bumping into other carts. It's this incredible cascade of control.
So when you put all of these pieces together, the speed, the senses, the logic, you start to get a real sense of the true complexity of your luggage's journey.
It's really not just one system. It's a system of systems. You have the high-speed hardware, the different kinds of sensors, the instant decision-making of the PLCs, and the big-picture strategy of the network controller. All of it has to communicate and work together in perfect, synchronized harmony. So what are the big takeaways from all this? First, these systems can be surprisingly fragile. Like we saw at Heathrow, one little software glitch can create a cascading failure and bring everything crashing down. Second, it's not just about being fast, it's about precision. Every single bag has a very specific time window to get to its flight. And finally, it's all just a massive balancing act between keeping us passengers happy and managing this incredible operational complexity behind the wall.
From the high-speed carts to the multi-layered software, these systems really are a hidden marvel of modern engineering. But they also show us just how much we rely on all this technology working perfectly together. So it makes you wonder, as our world gets even more connected and airports get even busier, what part of this invisible system will be the next one to break?